You wouldn't believe how much technology goes into making ordinary toilet paper. Robots cutting trees with laser precision, machines rolling them out at speeds of hundreds of miles per hour, and even artificial intelligence monitoring every single inch for quality. After this video, you'll never look at toilet paper the same way again. Watch till the end. It's going to blow your mind. Let's dive right in. The process starts at logging sites, where machines known as harvesters are used. These impressive machines cut down trees, strip them of branches, and chop them into logs of precise lengths, all in one go. Honestly, I could use something this multifunctional for cleaning my house. Logging is meticulously planned, using GPS and GIS to identify optimal areas for cutting while adhering to strict environmental standards. Trees are harvested selectively to prevent over-deforestation. Logs are then transported to pulp mills by specialized trucks equipped with GPS trackers that optimize delivery routes. Alongside fresh wood, these factories also use recycled paper, collected through recycling programs, delivered as compacted bales. At the mills, the logs are fed into automated lines, where they're chipped into small, uniform pieces. See how tiny these chips are? That's thanks to industrial-grade chipping machines, equipped with sensors to control wood size. These chips are moved along automated conveyors to massive digesters. Before entering the digester, the chips pass through magnetic separators to remove any metal and sieves that ensure uniform size. Sensors and computer systems manage every stage. Inside the digester, the chips are mixed with chemical solutions like caustic soda and sulfides, a process called the Kraft method. Automated dispensers precisely measure and add chemicals based on the type of wood being processed. Feeling the heat yet? Inside the digester, the chips are heated under high pressure for several hours. This entire process is automated. Computer systems carefully control temperature, pressure, and cooking time to produce the perfect consistency of pulp, a mixture of solid particles and liquid. Now, check this out. The pulp is pumped into centrifuges, which remove heavy impurities like stones, sand, or metal. Chemicals are then added to break down any remaining linin, the substance that binds wood cells together. Advanced sensors monitor temperature, pressure, and chemical concentrations to achieve optimal pulp brightness without wasting reagents. After this, the pulp is washed to remove residual chemicals and byproducts. Multi-stage washing systems clean and recycle water, minimizing waste. Oh, you're still here? Great. Quick story. One Halloween, I was completely swamped with deadlines. Instead of competing in our neighborhood's annual Best Holiday Decorations contest, I gave up. In a moment of pure laziness, I TP'd my own house, just like in those classic prankster movies. Surprisingly, it got more compliments than any decor I'd ever done. The irony, right? Anyway, back to business. Once purified and bleached, the pulp, which now has a creamy consistency, is piped to forming machines. Sensors installed in these pipes monitor temperature, moisture levels, and pulp density. The pulp is spread onto a forming table, the core component of the paper-making machine. This section consists of an endless wire mesh, moving at speeds of up to 63 miles per hour. The pulp is evenly distributed onto the mesh through nozzles, and excess water is removed immediately using vacuum pumps. The sheet then moves to the press section, where special rollers covered with silicone or rubber squeeze out more moisture. Next up, drying. The sheet passes through a giant cylinder known as the Yankee dryer, heated to temperatures between 240 and 300 degrees Fahrenheit. By the end of this stage, the paper's moisture level drops to around 5%. Sensors constantly monitor the cylinder's temperature and rotation speed to prevent overheating or overdrying. Now for the finishing touches. The dried sheet undergoes embossing, where textured patterns are pressed onto its surface. This step enhances the paper's softness, absorbency, and appearance. Steel or rubber rollers with intricate designs create these patterns. Automated systems ensure the patterns are crisp and evenly applied. Some manufacturers add fragrances or moisturizing agents at this stage, spraying them on in thin layers using advanced nozzles. Optical and ultrasonic scanners monitor parameters like thickness, density, and uniformity. If defects such as tears or uneven textures are detected, the system automatically adjusts or discards the flawed section. Data from all scanners is fed into a central computer, analyzing the entire line's performance in real time. It can even predict potential issues, like roller wear, and notify operators for maintenance. Cool, right? After forming and drying, the paper is rolled into massive jumbo rolls. These rolls can measure several feet wide and weigh hundreds of pounds. Robotic arms transport the jumbo rolls to the rewinding section, where the sheet is unrolled, smoothed, and prepped for cutting. Rewinding machines stretch the paper and roll it onto cardboard cores, which are automatically fed into the line. Check this out. These machines can wind hundreds of rolls per minute, and they're constantly monitored for tension or defects. If something's off, the system pauses to prevent waste. Once rewound, the rolls move to the cutting section. Here, larger rolls are sliced into smaller, standard-sized rolls using high-speed cutting machines. Titanium or steel-coated blades ensure clean, precise cuts without damaging the paper. These machines operate with millimeter precision, guaranteeing uniformity. Automated systems monitor blade sharpness, replacing dull blades without interrupting the process. Each roll undergoes final inspections via high-resolution cameras and infrared sensors, checking diameter, density, and cut quality. Defective rolls are swiftly removed using pneumatic arms. Finally, the finished rolls head to the packaging section. Robotic systems handle them without contact, reducing contamination risks. Sensors align the rolls before they enter the wrapping machine, while a computer system ensures all rolls meet size and weight standards. The rolls are grouped into packs, 4, 6, 12, or even 24, based on consumer demand. Robotic arms stack and wrap the rolls using either thin but durable plastic film or eco-friendly paper packaging. This ensures protection from moisture and dirt while catering to environmentally conscious buyers. Imagine a company at the center of a major scandal, but instead of fading away, it turns the challenge into an opportunity. Fairlife went from facing accusations of animal cruelty to becoming a leader in the dairy industry by implementing new ethical standards and winning back consumer trust. This is a story about how a crisis can become the starting point for positive change. Ready to learn how they managed to change the game and set new industry standards? Let's dive into this fascinating journey of transformation. Like any production process, Fairlife's manufacturing begins with collecting the main ingredient, milk. Fresh milk is sourced from farmers who adhere to high standards of animal welfare and product quality. Once the raw milk arrives at the plant, it undergoes the critical process of ultrafiltration. Ultrafiltration is a key stage in Fairlife's milk production that allows the separation of proteins, calcium, lactose, and other components. This process serves multiple purposes, removing some of the water from the milk, which makes the product more concentrated, significantly reducing the lactose content, making the milk suitable for people with lactose intolerance, and increasing the protein content by about 50% compared to regular milk. The ultrafiltration process is carried out using special membrane filters. These filtration systems utilize ultra-thin membranes through which the milk is passed under pressure, removing excess water and concentrating essential nutrients. After this, the milk moves into separators that help further divide the milk's components into different fractions, ensuring the right concentrations of protein, calcium, and fats are achieved. The next stage in Fairlife's production is fortification. This is the process of adding extra nutrients, such as vitamins and minerals, to the milk to boost its nutritional value. Common additives include vitamins D and A, calcium, and other beneficial components. These nutrients are introduced in either liquid or powdered form using special mixers. Before being added, the supplements are dissolved to ensure even distribution throughout the milk. Here's how the process works. Dosing devices calculate the required amount of additives based on the volume of milk being processed, which varies depending on the plant's capacity. The machine then measures the correct amounts of vitamins and minerals and introduces them into the ultra-filtered milk. Afterward, a giant mixer, known as a homogenizer, blends the liquid thoroughly to ensure even distribution of the additives, preventing clumping or uneven concentrations. Once mixing is complete, samples are taken for quality testing. This timely quality control step ensures that the nutrients are evenly distributed and meet established standards. The next stage is pasteurization. This is an automated process in which milk is treated at high temperatures to eliminate harmful bacteria while maintaining its freshness and nutritional value. Honestly, I was amazed at how much happens at the plant. You might think it's as simple as getting the milk from the farmer, bottling it, and that's it, right? But meanwhile, the ultra-filtered and fortified milk flows through pipes into the pasteurization block, where it pours into prepared containers. In the pipes, the milk passes through heat exchangers, where it's quickly heated by hot water or steam to 170 degrees Fahrenheit for 15 to 20 seconds. This quick heating process kills most pathogenic organisms. As for the remaining few, well, nothing is ever 100% sterile, just something to live with. After heating, the milk is rapidly cooled to about 40 to 42 degrees Fahrenheit, which helps preserve its freshness and prevents bacterial growth. The cooling happens in the same exchanger, but this time using cold water that circulates around the pipes. The pasteurized milk is then transferred into sterile storage tanks, where it waits until it's ready to be packaged. The finished milk is packaged into special airtight containers that ensure freshness and long-term storage. By the way, here's a personal tip. Always check the seal of the packaging before you buy it. Once, I failed to do this while visiting my parents for a family dinner, and let's just say the upstairs bathroom got a lot of use. But that's another story. After pasteurization, the milk is transferred from storage tanks to the conveyor belt through pipelines. There, it enters an automated packaging system that controls the entire process. On the packaging line, machines automatically supply and form either cardboard or plastic containers. The packaging is sterilized with ultraviolet light or steam to kill any potential microorganisms. Fairlife milk is dispensed into the prepared containers by high-precision dosing machines, ensuring that each container receives the exact same volume. Once filled, each container is hermetically sealed to prevent air from entering and to maintain the milk's freshness. Depending on the type of packaging, sealing is done using either adhesive or heat. After the containers are securely sealed, important information like the production date, batch number, and expiration date is printed. This labeling is done directly on the packaging line using either a laser or inkjet printer. The packaged containers go through automated sensors and cameras, which check for defects, proper sealing, and compliance with standards. Once inspected, individual containers are grouped into larger bundles or boxes for easier transportation. Robotic systems swiftly and accurately assemble these group packages. The finished bundles are then automatically stacked onto pallets, ready to be stored in the warehouse or sent directly to retail locations. I swear, friends, I've never seen packaging quite like Fairlife's anywhere else. It's so futuristic. It stands out from regular milk cartons as if it was dropped straight from a spaceship onto your table. Fairlife processes millions of gallons of milk each year to meet the demand for its products in the United States and other countries. Thanks to ultrafiltration, Fairlife milk contains 50% more protein and 30% more calcium compared to regular milk. Each serving of Fairlife provides approximately 13 grams of protein per glass, making it popular among people who follow a healthy lifestyle. Fairlife is actively promoted as a healthier alternative to regular milk due to its high protein content and reduced sugar levels. The company works with small family farms. ensuring high-quality milk and supporting the well-being of farming families. Thanks to its specialized processing, Fairlife milk has a longer shelf life, up to 90 days, compared to regular milk. The company emphasizes environmental responsibility by using technologies that reduce water and energy consumption during production. Fairlife quickly became one of the leaders in the ultra-filtered milk market thanks to its innovative approach. However, the company found itself in the spotlight after allegations of animal cruelty at its supplier farms surfaced. In response, Fairlife took action to improve animal welfare and implemented new standards for monitoring its farming partners. The company is actively working to regain consumer trust by introducing initiatives aimed at enhancing animal well-being. Fairlife continues to expand its product line, adding flavored milk options, yogurts, protein drinks, and other dairy products. This is California, USA, where around 1.7 million cows on thousands of dairy farms produce more than 13 million gallons of milk every day. So, how does this massive amount turn into the sweet treat that once saved soldiers' lives and changed history? I visited one of the largest factories in the world to dive into the fascinating process of making condensed milk and to share the story with you. In 1856, American inventor Gale Borden first came up with this product. His creation solved the dilemma of preserving milk in the days before refrigerators, making it possible to store milk in cans for at least a year. During the American Civil War, it played a crucial role in supplying soldiers with milk in combat zones where dairy cows were not available. Thanks to its long shelf life and valuable nutritional properties, it became the preferred choice for feeding soldiers. The process of making condensed milk begins on dairy farms. To meet the high demand for this delicious product, factories like Nestlé's in California operate around the clock, 24 hours a day, 7 days a week. This factory processes more than 420,000 gallons of milk daily. Massive tank trucks arrive non-stop, transporting between 130,000 and 185,000 gallons of milk each day from nearby farms. Most of the incoming milk was collected just 6 hours earlier, so it's incredibly fresh. However, before the milk is accepted, it undergoes lab testing. The fat and salt content must meet factory standards, and the milk must be free of antibiotics to avoid allergic reactions in some people. But where do the farmers get such milk? Most of the milk in the US comes from roughly 60,000 dairy farms, where over 9 million cows are raised specifically for milk production. Over the past century, the milking machine has become an essential tool. The part of the machine that attaches to the cow's teat is called a cup, and it works similarly to a hand, applying pressure to the udder to extract milk. A farmer can manually milk about 6 cows per hour, but with a specialized device, that number can jump to 100 cows per hour. The ingenuity of this innovative device has optimized milk production, but the way a farmer cares for their cows also impacts the quality of the milk. The more care given to the animals, the longer their lifespan and the more milk they produce. On this massive dairy farm, 8,000 cows graze. It's one of many farms that use technology to improve cow living conditions and boost productivity. In cow carousels, known as milking parlors, up to 80 cows can be milked at once, twice a day. Dairy cows are creatures of habit, and they enjoy sticking to a routine, which makes the milking process smoother. These advanced milking parlors outperform traditional machines, increasing the milk flow rate by 30%. Before attaching the milking cups, workers disinfect the cow's udders with an iodine solution. This process mimics the sucking motion of a calf to ensure organic milk production. The entire procedure takes about 7 minutes, and after milking, the cups automatically detach. These animals spend around 8 hours a day eating. Consuming 100 pounds of feed and 80 gallons of water, a cow can produce up to 10 gallons of milk a day, 7 days a week. Thanks to technological advancements and more nutrient-rich feeds, today's cows are 3 times more productive than they were 50 years ago. A dairy cow starts producing milk at around 2 years old, once she gives birth to her first calf. Typically, the calf is separated from its mother within an hour of birth to prevent harmful bacteria from reaching the mother's udder. From then on, the calf is bottle-fed with its mother's milk, while the cow begins her career as a milk producer. For 305 consecutive days, the cow is milked twice a day, after which she gets a well-deserved 60-day break to give birth to another calf. Once the cow delivers, the milking process begins all over again. The liquid produced by cows is a nutrient-rich substance that consists of 87% water. This process begins when food is digested in the cow's stomach and transformed into nutrients, which are absorbed into the bloodstream. These nutrients travel to the mammary glands, where they are converted into the valuable liquid we know as milk. Milk is collected from the udder at a temperature of 90 degrees Fahrenheit and transported via pumps into storage tanks, which are then cooled. In these tanks, the milk is stored at a safe temperature of 36 to 37 degrees Fahrenheit. However, at this stage, the milk is still in its natural state and may contain harmful microorganisms. That's why it is loaded into a 5,300-gallon tanker truck and taken to a dairy processing plant. After the milk has passed all stages of quality control, it is sent to a centrifuge separator to speed up the separation process. In the top section, cone-shaped discs spin at an impressive speed of 7,000 revolutions per minute, processing over 5,800 gallons per hour. Under the force of centrifugal action, the heavier skim milk moves outward, while the lighter cream moves toward the center. As a result, we get cream with a fat content of around 20% and skim milk with a fat content of less than 1%. The skim milk serves as the starting point for making condensed milk. Next, the milk undergoes the pasteurization process to destroy any bacteria present. To begin this procedure, the milk is first cooled to a temperature of around 37 degrees Fahrenheit, then passed through a heat exchanger that raises its temperature to 162 degrees Fahrenheit. After heating, the milk is transferred to a chamber where it is held for 15.5 seconds, achieving the required level of pasteurization. The milk is then cooled back down to 37 degrees Fahrenheit. In less than 40 seconds, complete pasteurization reduces the bacteria count in the product by 99%. Before the introduction of pasteurization technology, most consumed milk was in its natural state, leading to quick spoilage and exposing people to the risk of infection from potentially dangerous microorganisms. In 1862, the famous French scientist Louis Pasteur proposed an innovative solution originally aimed at preventing wine from spoiling, which was later applied to milk. After milk is pasteurized, a large amount of sugar is added to it. The sugar not only gives the milk a sweet taste, but also acts as a preservative, helping to extend its shelf life. The mixture of milk and sugar is reheated so that the sugar fully dissolves and becomes uniform. The heat not only helps dissolve the sugar, but also prevents the formation of crystals that could affect the smooth texture of condensed milk. After this, the milk enters an evaporator, an enormous device designed to remove water from the milk. At this stage, the milk becomes thicker as the water content is reduced by about 60%. Using heat and pressure, the evaporator manages to evaporate the water from the milk without altering its properties, allowing the concentration of solids like proteins, sugars, and fats. This process gives condensed milk its thick texture and delightful sweet flavor. The evaporator consists of a series of vertical structures called calandrias. Inside each calandria is a set of stainless steel tubes through which the milk circulates. A steam chamber surrounds these tubes. The milk enters each calandria from the top and flows down through tiny channels. As it moves downward, the steam enveloping the tubes heats the milk, causing the water within it to evaporate. Once the milk reaches the desired thickness, it is removed from the evaporator. Next, the milk undergoes an additional process called homogenization, where the fat is broken down into small uniform particles to improve its consistency and stability. Before the condensed milk is packaged, the containers must be sterilized to eliminate any microorganisms that could affect the product's quality. Once the condensed milk is processed and has reached the perfect consistency, it is transferred to a packaging machine. These machines precisely measure the required amount of product into each container, ensuring consistency and reducing waste. After filling, the containers are sealed tightly to prevent any contaminants from entering. To ensure the product's safety, the filled and sealed containers undergo an additional sterilization process. The cans are placed in autoclaves, where they are exposed to steam under high pressure to destroy any remaining microorganisms. This procedure ensures that the condensed milk inside the container is completely safe to consume and has a long shelf life. In addition to meeting domestic demand, condensed milk is widely exported around the world. Thanks to its long shelf life and high nutritional value, it is a popular product in countries with limited access to fresh milk. Condensed milk-producing countries like the United States and several European nations actively supply this product to markets in Asia, Africa, and Latin America. The export of condensed milk helps strengthen international trade relationships and ensures that people in various regions have access to quality dairy nutrition.